So hey guys, this is Biswajit. Welcome to my YouTube channel. So this is going to be a video of my machine learning project playlist, and I already explained what I did. So if you have not checked out my last video, do go and check it out. Otherwise, you won't be able to understand how I came over here. So now in this video, I'm just going to continue from the point where I left off in the previous video. We were here in the merge player data. So this data is in each and every individual player's data, right? So this is one player's data, this is another player's data, this is another player's data. So this is the initial pre-processing data, right? So now I'm just checking the shape of it, how this data looks like. So I have a shape of around 11,060 rows and 37 columns, and here I can see the target. Even I have the target, right, for this. So the target is around 11,060 and 1 is the target row. Let me show you this. It's over here, right? Now, before moving on into more detailed machine learning and stuff, what we need to do, we need to divide the data into training data and test data, right? So that is done using the train test split. Extremely important function that has been given. What it is going to do, it is going to split the data into train test, and it is going to randomize the data, right? Rearrange the data so that our machine learning algorithm does not learn something different which we don't want it to learn. So it is going to be a randomized data, because there are certain data that are present sequentially. So the learning model fails to learn what we intend it to learn. So for that, we need to randomize the data so that it learns in an unbiased manner. Okay, so let me execute this. So our data is divided into training set and test set. So we have the xtrain dot shape. If I do, you can see we have around 88,048 columns. So around 11,000 was the original data. It got divided into training data and test data. So this is the training shape, and let me check the test shape. So around 2200 is the test shape. So fine, that is not an issue. And even we have the test target and the train target. So now this is the pipelines that I have used. So I used pipeline and I used column transformer frequently in my projects or in any kind of assignments, because they are extremely handy. So what the number pipeline does, so here in this data we have the categorical data and we have the numerical data, and we have to handle the categorical data in a different way and numerical data in a different way. So in generally, when we are doing numerical data handling, so first of all, our data set is given to us. The data set, as I showcased you, it contains many null values. So we need to handle those null values first. So I am using simple imputer strategy equal to mean to handle the null values. Now the null values gets handled by this functionality. Now we have to use a standard scalar. So this is actually important, because generally machine learning model uses a sort of optimization gradients inside internally. So we need to scale the data properly, because if the data is not scaled, then the model is not going to converge fast, or it may not reach the optimum solution. For example, you can see, let me consider this. Yeah, you can see this GK driving has it's starting from 15, 12, 14, 14, 8, 12, 9. So I can see its scale ranges between somewhere around from 5 to 20, I can assume. But you can see the sliding tackle, this has a different scale, 67, 71, 21, 68, 74, 72. So the scale is extremely different. So first of all, we need to change the scale, change all of this scale to, we need to scale down this to the same scale, right? We need to bring down the scales to the same level. So to do that, I used the standard scalar. It is going to scale down all of the data to the same scale. So the missing values over here is handled, and the scaling is handled, right? So now categorical pipeline. So what it does, pipeline here. So I am doing simple imputer. This is to handle the missing attributes. For example, there is some kind of null categorical attribute, so this is going to handle that. So I am just filling those null rows with mode value, most frequent. And this is another technique, one hot encoder, to encode our categorical data properly. So this is handling my categorical attribute, and this is handling my numerical attribute. If you want more detail about number pipelines, categorical pipelines, do comment in the description if you're not able to understand. So if you respond, I'll make a video in future. So now these two are separate entities, right? These two are separate pipelines. You can call them individually number pipeline, then categorical pipeline, but we don't need to do that. We actually have a very useful thing. We have something known as the column transformer. So here we just pass the object and the columns on which we want those changes to happen. So number pipeline, I want the changes to happen on the numerical attribute, and categorical pipeline, I want the changes on the categorical attribute, right? And similarly, I am doing the same thing for my target. So these are my training data, and this is my, so these are going to handle the attribute data attribute, and this is going to handle the target. So let me define those. And the beauty of it is, in one line, in one shot, you can do it. So full transformer data, full transformer, which is nothing but this, dot fit and transform, or xtrain. Xtrain is nothing but which is this data, this divided data. So, and in one shot, it is going to give me an array, right? So here the data is imputed, scaled, categorical data is imputed, one hot encoded. So in one shot, I got it. Now the same thing I have to do for the target also, right? Even we have the target, right? The overall rating, that is the target. So even I have to do that also. So what I did for target, there is a target object. Here I am simply using the pipeline because this is only one process and there are no multiple pipelines I am using. This is just a single pipeline. So I have just used the pipeline object. So target pipeline dot fit and transform, and this is going to give me the target attribute. This is a imputed and scaled data. So now what I am doing, I am importing job leave, and this is a function. What this function does, this function generates file names, right? So this function generates actually date and month. So if you want to save something and if you want to generate proper file name, so I have used this function. I'm gonna show you how this function works. So I'm just defined this function, and here I'm just saving the data over here, right? So joblib.dump, this is gonna save the data. That's it. So what data I'm saving? So as I showcased over here, I'm using pipelines, right? This pipeline I'm using. So I have to use these pipelines in my deployment also. So for example, when the user gives me a raw data, so I have to do scaling also, right? So I have to do the scaling also. I have to do imputation if it is required. So I have to save this whole transformer, right? This whole transformer needs to be present during the deployment also, so that if a player gives me raw data, I'm able to do that pre-processing, the same type of pre-processing that I have done during the training. Otherwise, our model is going to predict wrong. So for example, this is the full transformer that I have used. Now I need to save this. So first of all, I have used two classes. As I showed before, there are two classes, initial pre-processing. These two are for initial pre-processing, right? So I have initial pre-processing, so I am saving these two classes. I should say I am saving these two class objects that I created. So there are two objects that I created, custom attribute object and merge target object that I showed over here. Merge target object and custom attribute object. These two objects I need to save because I have to do initial pre-processing if it is required. I can't pre-process every time that I get a data from the user. The model needs to be present. It's going to be a little bit complicated, but bear on me, I'm going to explain that part. So this is the custom attribute object, right? I'm saving this object. This is the merge target object. So I need to save these two objects, right? I need to save these two objects. These are going to these objects I require in the deployment. If I get a raw data from the user, I need to do the initial pre-processing, right? So I need to save these objects. Now these two are my transformers that I used over here, right? These two are my transformers. These two. I'm saving these two objects also. Okay. So there are total 4 files that I will get, and I require these 4 files in my deployment. So if I execute this, you can see these files got created. Now I'll show you where these files got created. If I go on pipelines, so I'm executing this code for the first time today. So see 9/11 2022. So these are the 4 files that got saved, and we need these files to pre-process the data, because in the deployment also you need to pre-process the data, right? So you can't train from first, you need to pre-process then and there only. So now what I am doing, hope this part is understand. Now full transformer.shape, I'm just checking the shape of my target. Full transform data is my this data, full transform data. That is the data that is completely prepared for machine learning. And this is full transform target. This is the data, target data, prepared to get into the machine learning model. So I am showing you the shape of my transform data, and this is the transform target. So there are 43 columns over here, and there is one column over here. Let me show you how the data actually looks like. Full transform data, right? So actually you won't be able to understand much of it. So this is the first entry. This is the whole data, right? Because this is extremely tedious. You can't see, already this data is hidden. So I am going to show you the first row. So this is the first row. So you can see these are all my numerical attributes, and these are my categorical attribute. So I can make out because I have worked a little bit and I know how it looks, and there will be negative values, positive values, because these are all scaled values. These are all standardized values. So this is how the full transform data looks like. So now this data is completely ready to be fed into the learning model. So in the next video, I'm going to explain how I did my machine learning and how I selected the best model out of it. So thank you for watching this video. So in the upcoming video, I'm going to showcase this. So thank you for watching. See you next time.